Okay, in this video we will talk about variables and operators, the operations that you can perform on variables. A variable in a very layman term is basically a symbol that stores some data that can be used later on. So for example, this X is a symbol, character or a symbol, Y is a symbol, X, Y is a symbol. Normally, and these are called names of the variables. For example, this is a variable name X, Y is a variable name Y, X, Y is a variable name itself. Now, these variables, they can store different kind of data. I mean, whenever you want a particular data to be used again and again, it is better to save that data or label that data by a symbol, by a descriptive name, so that you can retrieve that name, retrieve that data by using that label or symbol. So one way or the other, this variable actually is a description of the data that you want to use or store and you want to use later on in your program. Different types of data are there. For example, the integer type data. For example, if the data you want to store is integer type, it's a number, and the number is just the integer number. It does not have a decimal point expansion. That is a type of data, and that can be stored in a variable. In that case, the variable type itself will be integer. You need not to specify the type of variable when you are storing the data to it. Storing data to a variable is sometimes called assigning data to a variable or assignment. For example, if your variable is X and you are assigning a value, let's say 2, then 2 is integer value. It's integer, it does not have a decimal expansion. And when 2 is assigned to X, based on the content 2, that 2 basically is an integer type value, automatically the type of X is set to be integer. And that is sometimes called the dynamically typed. Python is dynamically typed language or dynamic typing. You need not to specify the type of the variable. The contents that you are assigning to a variable, they will define the type of the variable on the fly. And the assignment, for example, in here I am storing 2 inside X, and next time if I want to print, for example, what is there in X, the print value will be 2. Now, this kind of symbol is hard to write. There is no keyboard symbol that looks like so. So rather than writing this symbol for assignment, normally an equal sign symbol is used for assignment. For example, X is equal to 2, that means 2 is assigned in X. Y is equal to 5 means 5 is assigned in Y. 7.2 equal XY equals 7.2. XY is completely a new variable. It has nothing to do with X or Y. And it is handy sometimes to suggest the name of the variables that are too descriptive, that are very, very descriptive, to increase the readability and management of the code. Because later on you'll be seeing, when you will be working in data science and other stuff, the programs that you will be writing might not be very short programs, they might be lengthy programs. So readability of a program and management of a program becomes an issue if you do not assign the names of the variables carefully. However, if you write the names in a very descriptive way, by just reading the name of the variable, by just reading the variable symbol or the name, it tells a better look and feel of what kind of data inside and what should I do with that. So I was talking about this equal sign. This equal sign is used for assignment. Here, for example, when 7.2 is assigned to a variable xy, automatically the type of xy variable is set to be a floating point number. A float is a data type in Python that describes that the particular data is a real valued. It may have a decimal expansion as well. Not just integer and floats are the only data types in Python. There are several others. For example, you can define complex numbers if you want to. You can, for example, defining a complex number might be, for example, you write the name of C and you write 2 plus 4j. If you write the symbol j here, it automatically becomes complex. And now you can use this C the way the complex numbers should be treated. Similarly, there are other data types like fractions, decimals. There are further data types, the objects called strings. For example, if you assign, let's say, s equals double quotes hello, then that s is also a variable, and the type of this variable is string. String is just a sequence of a lot of characters, where H is a character, E is a character, L is a character, L is a character, O is a character, W is a character. And when we will define anything, any sequence of characters inside the double quotes and then end the double quotes here, or the single quotes and double quotes, either way, then the type of this S becomes strings, and these characters should be treated as it is. Like, for example, if we have another variable s2 and we just say 1 2 in double quotes, now this s2 is no longer 12 as an integer. It is a sequence of characters where first character is 1 and other character is 2. We will talk about strings in detail in the upcoming videos, but just to give you a look and feel that Python actually supports a lot of data types, a lot of interesting data types, including the most important data type is integer, float, and string as well, that we will see in detail. Further, you can assign more than one values to more than one variables in a single line. That is sometimes called multiple assignment. For example, if you write a comma b equals 4 comma 5.0, then 4 will be assigned to a and 5.0 will be assigned to b. Notice one thing, although 5.0 looks like an integer, but when you write a decimal expansion, it automatically becomes float. So if you now type if you now check the type of a, it will be integer, and if you check the type of b, it will be float. Once you have declared a lot of variables, they stay in the memory, they occupy a particular space inside the memory. For example, x is just a label to a memory. Inside the memory there is 2 located somewhere. Similarly, y is also located somewhere in memory, and similarly xy is also located somewhere in memory, and this is the data inside that memory. These will stay in the memory and they occupy the memory. If you decide to no longer use a particular variable in future in the program, then you can call this function del space whatever the variable name, and it will delete the variable from the memory like it was never there. And once the variable is no longer in memory, it is not accessible. If you now access the variable again, you will get an error. Let's see all these concepts. Let's see most of these concepts in Jupyter Notebook, and let's actually define certain variables, use them, print them, do some multiple assignment, and see a lot of stuff in Jupyter Notebook. So let's go to Jupyter Notebook. So that was our notebook that we were actually working on the last time. So let's say I define a variable x. Let's say x is 2. Why not I should describe this as what we are doing here is, let's say, variables. So just to give a heading that we are now in variables. So variables, notice that now I'm in a code cell. Previously I was in a markdown cell. Notice this change. In this particular cell, this is markdown. In this particular cell, this is code cell. See that, code cell. Okay, x is equal to, let's say, 3. Let's enter this. Now x is assigned a value 3. If you want to know how many variables right now are there in the memory, we can write this command whos. This is a percentage symbol. If you write percentage symbol and then just type a command whos, it will tell you all the variables that are right now that are there in the memory. And right now the memory has a variable with name x, its type is integer, and the data inside the variable is 3. That's the memory view that you're now seeing. Okay, if you want to explicitly check the type of x, you can print type x. So for example, this function type will actually finds out the type of whatever variable you give inside, and then the print function will help you printing that on the notebook. So if you see the type of x, the type is basically its integer type. Now if you, for example, change the value of x as 3 to, let's say, 5.7, so you have same variable, but you just change the value from 3 to 5.7. So let's see what happens now. So if we call whos again, we have now the variable name is still x, but its type automatically changed to floating point number because we assign a floating point number to it, and this is the data. If we want to explicitly check the type of this x, that would be class float now. Further, let's say we have another variable a, b, c, d, that's a variable name, let's say, and we assign a value 556.32, that's a value. If we now call the whos function, whos command, we will be having two particular values. One variable as abcd, its type is float. Another variable is x, its type is float, and that is there. If we, for example, do a multiple assignment, for example, a comma, when you write comma, first variable finishes, second variable starts. A, B, C, D, F, let's say these are 5 variables, and if you assign 5 values to 5 variables, again in a comma separated list, 3, 5, 6.0, 7.2, and let's say -3. So if you enter that and you now check the status of the memory, because now all these values are assigned to their respective variables. If you now check the memory view, a is an integer type variable with value 3. abcd, the old variable that we assigned earlier, it's already float. B is also integer, it has value 5. C is float, although 6.0 looks much like integer, but when you write a point explicitly, it becomes a floating point number. So D is again float with 7.2, F is integer, it's -5, and X is the old variable that we know already. Now if we, for example, delete a particular variable, if we, for example, we no longer want to use ABCD variable, ABCD, that's one variable that we don't want to use in future. And now if we see again the view of the memory, we don't have this, and if we now want to access this, for example, if we want to print this A, B, C, D, we will get an error. And we should get an error, because this particular variable does not exist in the memory. It points to no data. It has gone. Like it was never there. So that's about the variables. We just talked about integer and float. There are several other variable types as well. For example, let me just give you an example of a complex number, if you are really interested in. That's a complex number. If you print its type, so that the type is complex. Similarly, you can have a string variable. Let's say hello, how are you? That's a string variable. If you print type of this, you will get a string. We have a whole set of videos just on string data type, because this is very important data type. We will see that in detail. But the purpose here is just to tell you that there are a lot of data types that Python supports, and Python is dynamically typed. Whatever content you are assigning to a variable, that content decides the type of the string. You need not to specify. So I end this video here. In the next video, we will be talking about operators, basically what kind of, so once we have decided, once we have declared, once we have defined a lot of variables, what we can do with these variables. Can we add two variables together and get the result stored in another variable? Can we multiply two variables together? Can we have an operation like addition on mixed types? For example, one variable is a floating point number, another variable is integer number, integer type. Can we mix up those? Can we add two different types of variables together and get a result? Then what will be the type of the result, and so on. So a lot of these discussions on operators, the very basic arithmetic operators on these variables, particularly the integer and float variables, we will see that in the next video. So hope to see you in the next video.